Hey folks, probably shouldn't do this because it dates my presentation, but Happy New Year! Today is December 1st. Welcome to my discussion on some of the year's digits, depreciation, often written SYD. And to calculate depreciation using the sum of the year's digits. Sum of the year's digits is generally accepted accounting principles sanctioned because it is systematic and rational. And that is the only requirements of the depreciation method, believe it or not. By the time we're through, I'm going to see if you think it's rational. It's the least popular of the depreciation methods. My personal opinion is because it's kind of hard to calculate partial year. Let's see what you think. We're going to do this both ways, so you'll have a good opinion of it. We're going to calculate depreciation for a full year. And then we're going to calculate depreciation for a partial year using the same facts, except purchasing whatever we purchase on April 1st. Hold on, I'll give you some facts. And our facts are the cost of our equipment we purchased is $16,000. Our salvage value is going to be $4,000. We're going to use 5-year life and use the sum of the year's digits method to calculate depreciation. Let me give you the formula. Our formula is cost minus salvage times some fraction. Give you depreciation expense for the year. Now, let's talk about that fraction. The fraction is the sum of the year's digits. Since it's a 5-year piece of equipment, that would be 5 plus 4 plus 3 plus 2 plus 1, starting with 5 because it's 5 years, and that equals 15. That gives you the denominator to the fraction, and the numerator is however many years you have left. So, that's a drag, especially if it's 120 months or something like that. So let me give you a formula for coming up with the sum of the year's digits. You take n, the years, times n plus 1, and divide that by 2. In our case, 5 years times 6, because I added 1, divided by 2 equals 15. And you can see, great shortcut to get the sum of the year's digit denominator. So, you take cost minus salvage times a fraction equals the depreciation, and the denominator for our fraction, shown two different ways, is going to be 15. And the numerator will be how many years is left. I'm going to put you on pause for a second and make a little table. The table is going to show the year. We have 5. I'm going to do it for the cost minus salvage will be 16 minus 4. I'm not going to do that every time because that'll make us all crazy. Just going to put 12 here. And I know you know that means cost minus salvage, or in an accounting term, depreciable basis. And each year we're going to times that by a fraction. In the first year, it's going to be 5 years left to go, 15th. 15 already calculated from our formula. The second year times 4/15, 4 years left to go. 15, sum of the year's digits. Third year, 3/15. Fourth year, 2/15, 2 years left to go. Last year, and there you go. As you can see from our fraction, this is going to be an accelerated method. The first calculation will be 12,000 times 5 divided by 15. There's a lot of ways you could do that. That's how I'm going to say it. 12,000 times 5 divided by 15 gives you $4,000 depreciation for the first year. 12,000 times 4 divided by 15, 3,200 for the second year. Put me on pause and finish. See how you do. Welcome back. How did it go? Depreciation for the first year, $4,000, then 3,200, then 2,400, then 16, then 8. Systematic, rational. Did you get the numbers? And that's how you calculate depreciation expense. And it would lead to a journal entry each year that says depreciation expense and accumulated depreciation. I already know you know that, but just for posterity, we'll show that. $4,000 the first year, $3,200 the second year, and so on. And that is how you do a full year's depreciation. Let's do a partial year now, shall we? And our partial year will be same facts, but we're going to purchase the equipment on 4/1. See how that changes things. I'm going to put you on hold and reproduce the schedule that I just made so you won't get bored. I understand that you know how to do full year, and this was a course. Full year, and then come back and show you how to do partial year. And you can tell me if you still think it's rational. Hold on. Welcome back. And you can see my table. I have the year, the cost minus salvage, the fraction. I haven't calculated depreciation, but I have brought down what it would be for a full year, and notice it matches my table above. The problem is, I bought it on April 1st, and so I need to do a partial year. So I take the 4,000 and take 9/12 of it, and I take that for the first year. And 4,000 times 9/12 equals 3,000, and I use that for my first year depreciation expense. Fair enough, but when you look at that, your astute self can see I've only used 9/12 of that 4,000. So I still need another 3/12 of that. But that would only give me 3 months, and I need a year. So I take 9/12 of the next layer. What I'm going to do then is I'm going to go through and I'm going to calculate 9/12 and 3/12 of my full year depreciation, and we'll see how that looks. 12,000 times 5/15 the first year's 4,000. 3/12 of that would be 1,000, and the 1,003 is the whole year. I get it. That equals 4,000. Let's move to the second year. 12,000, 4/15 is 32. 9/12 of 32 is 2,400, and 3/12 of 32 is 800. For my second year, I need 12 months, 3/12 from the first year, 9/12 from the second year. So for the second year, I need to pick up 3,400. Whoa. That was interesting. I'm doing it in layers. I'm still splitting the year into 9/12 and 3/12. Let's do the next year. So the second year I'm taking 3,400. I've taken this, I've taken this, and I've taken this. But I haven't taken that 800 yet. 2,400 times 9/12 is 1,600. 2,400 times 3/12 is 800. 16 and 8 is 24, so it equals the whole 24 amount. I need to take this amount for my third year, which will equal 2,400. Wow, 3/12 from the previous year, 9/12 from this year. Yow, really? Well, let's do the next year. The fourth year would be 12,000. 2/15 or 1,600, and I need to split that, and it's 9/12 and 3/12, so I can finish last year's. 9/12 of 1,600 is 1,200. 3/12 of 1,600 is 400, and the next year's will equal 3/12 and 9/12 for a total of 2,000. So I have used up 9/12 of the prior year's layer, 3/12 of the prior year's layer, and 9/12 of this year's to come up to 2,000. Let's take the fifth year and split it up in its 9/12 and 3/12 categories. It's going to be 600 and 200. And I'm going to take this portion for the 4th year, or 1,000, and that's going to leave 200 left to take in, yes, the 6th year, a little bit. So, 1st year, 3,000, 2nd year, 3,400, 3rd year, a little bit equaling 24, 4th year, a little bit equaling 2,000, 5th year, a little from each one equaling, what does that equal? Heck, it's dark, 1,000. And the last year, get a little stub, 3 months, 200. Holy cow. So I took 3,000, and then I took 3,400, and then I took 2,400, and then I took 2,000, and then I took 1,000, and then I took 200. Add those up and tell me what you get. An astonishing 12,000, just like what it should be. Let's put this on a timeline for that fraction of the year and see how it looks. Let's see if you can follow this. The 1st year, it would have been 4,000, but I only got 9 months, so I took 3,000. That's 9 months. The 2nd year, I took 1,000 that was left from the 1st year. That now equals 4,000, which ties to my 1st year total. That's only 3 months. So I took part of the next layer, which was 2,400. So in that 2nd year, I took 3,400. 3 months from the 1st layer, 9 months from the 2nd layer. Let's move to the 3rd year. In the 3rd year, I took the last 3 months of year 2, 800, and 9 months of the next year, 1,800, for a total of 8 and 18 is, what is that? I'm a dork. My 18 used to be 16, 2,400. God, I cannot do this. So, by taking 24 and 800, I finished off that layer of 32, which ties to my full year. And I've taken part of it in the 2nd year, part of it in the 3rd year, and equal 2,400. The 4th year, I am taking the remaining of the 3rd year and 9 months of the 4th year. 16 and 8 is 2,400. You can tie that to our first schedule. Took the 4,000, we've taken 32, we're now down to 24. And part of the next upcoming year, so we're taking 2,000 depreciation for the year, but we're layering it. Let's move on to the 5th year. Looks like this. I have 400 from the last layer to take. 1,200 and 400 is 12 and 4. Hello, 1,600. Happy New Year. So I finished off that layer and taken 9 months of the next layer, so depreciation for the 5th year is 1,000. And then I have a little stub left to take the next year for 3 months, and 6 plus 2 is 8. This ties to full year. And this shows you how it was layered for each of the years partially. Depreciation expense and accumulated depreciation. When you buy it on April 1st for the 1st year, would be 3,000. As shown for the 2nd year, 3,400 more months are involved. For the 3rd year, let's see, 2,400. And add them all up, and they total 12,000. If you add them up this way, they total 12,000. And if you add 3,000 plus 34 plus 24 plus 2 plus 6 plus 2, put me on hold and do that. The sum of these also equals 12,000. We just layered it. So, some of the year's digits does a layered approach. and it's a partial year. Systematic? Yes. Rational? I suppose. Thanks for joining me on this discussion of some of the year's digits. It is a completely accepted, widely used, and in some places incorporated into the Internal Revenue Code method of calculating depreciation. We've looked at the full year, we've looked at the partial year, and we made a timeline helping you see it really does, between these layers, pick up all pieces, albeit systematic and rational. Happy New Year to you. Talk to you soon. Bye for now.